Have you ever walked into a room and just felt amazing, like you could get anything done? And then you walk into another one and you just feel instantly tired, maybe a little distracted? Well, that's not just in your head, and it's definitely not magic, it's science. Today, we're going to pull back the curtain on the invisible forces that are shaping how you feel in every single room, the air you're breathing and the light you're seeing by.
So this is the big question, right? Why does your office leave you feeling totally drained, but maybe a quiet library feels super energizing? The answer, it turns out, is hiding in plain sight. It's all about two key things that we usually take for granted. So let's unpack the science behind it all.
All right, first up, let's talk about the very air we're all sitting in right now. We all know fresh air is supposed to be good for us, but what does that really mean? It's a whole lot more complex and way more interesting than just cracking open a window. So here's the deal with ventilation today. It's not just about swapping old stale air for new air. It's an active process. It's about controlling that air. Think of it like a room's own respiratory system. It has to manage the temperature, the moisture, and even how clean the air is, all to create an environment where we can actually do our best work or just relax. Now, this is where things get really fascinating. For the longest time, the big idea was that we had to keep carbon dioxide levels super low. I mean, it makes sense, right? We breathe out CO2, so lots of it must be bad. This led to this crazy standard of needing 3,000 cubic feet of fresh air for every person every hour. But then, scientists did some tests and discovered something wild. People felt totally fine in rooms with high CO2 as long as the air had good cooling power. And just like that, the old theory was out, and a brand new, much more practical standard took its place. So what is that new standard? It all comes down to this number, 4 to 6. This is how many times the entire volume of air in an ideal room should be replaced every single hour. 4 to 6 complete air changes. Any less than that, and things start to feel stuffy and stale. Any more than 6, and you start feeling an annoying draft. This, right here, is the sweet spot. Okay, get ready for a bit of a mind-ender. We tend to think that a room with a super high ceiling feels more airy and fresh, right? But when it comes to actual, effective ventilation, any height over about 10 or 12 feet is pretty much wasted space. Why? Well, because all the stuff we exhale, the warmth, the moisture, the CO2, it doesn't just shoot up to the ceiling. It hangs out in the lower levels, right where we're breathing. So the thing that really matters isn't the total volume of the room, it's the floor space you give each person. So we know we need those 4 to 6 air changes every hour. But how do we actually make that happen? Well, there are basically two ways to go about it. You can either work with nature or you can engineer your own solution. Let's take a look at how our buildings actually breathe. Nature actually gives us a few tools for free. First, you've got the wind. When it blows straight through a room, that's called perflation, your classic cross breeze. When the wind goes around a building, it creates a little bit of suction that pulls air out. That's aspiration. Then there's diffusion, which is just air slowly seeping through tiny cracks and openings. It's not super powerful, but it helps. And finally, you've got simple physics. Hot air rises, so it escapes through high openings, pulling cooler, fresh air in from down low. Of course, we can't always rely on a perfectly breezy day, and that's where mechanical systems come in. The simplest approach is an exhaust system. You've got fans that just pull the stale air out, which creates a vacuum that sucks fresh air in. The opposite of that is a plenum system, where fans push fresh air in. This creates positive pressure that literally shoves the old air out. A balanced system, you guessed it, uses both at the same time. And then the top tier, the ultimate level of control, that's air conditioning, which handles everything: air changes, temperature, humidity, and even purity. All right, we have covered air. Now let's switch gears and talk about the second invisible force that totally dictates how we feel in a room: light. Seriously, if you're constantly feeling worn out or getting headaches at your desk, there's a really good chance that bad lighting is the culprit. It puts a huge, unseen strain on both our eyes and our brains. So what actually makes for good lighting? Well, it really just comes down to these 6 rules. I mean, of course, the light needs to be bright enough, and it should be spread out evenly. But 2 of the most overlooked rules are glare and color. Glare, that awful, painful brightness from a bare bulb, is a massive source of eye strain. And the color of the light is huge too. Our eyes evolved for natural daylight, so they're most comfortable with artificial light that mimics that color. If you can get all 6 of these right, you've got a perfectly lit space. So to hit all 6 of those rules, we're juggling our 2 main light sources: the sun and the light bulb. Natural light is amazing, but it's not always there when you need it, and it's not always enough. So let's look at how we can use artificial light the right way, starting with the bulb itself.
And wow, this one chart just illustrates perfectly why the type of bulb you use matters so much. Just look at this. A classic old school filament lamp converts only about 5% of its energy into light. The other 95%, it's just wasted as heat. It's basically a tiny space heater that happens to glow. A fluorescent lamp, on the other hand, is more than 4 times as efficient. It's a huge, huge difference.
So how much light is sufficient? Well, that totally depends on what you're doing. This table gives us some great reference points. For just some casual reading, 100 lux, that's just a unit of brightness, is perfectly fine. But for general office work, you need 4 times that much light. And for really fine, detailed work, you could need up to 2000 lux or even more. It just goes to show you how important it is to match your lighting to the task at hand. If you take away just one thing about lighting, let it be this fantastic rule of thumb. When you're in doubt, it is almost always better to have too much light than too little. But, and this is the crucial part, you absolutely have to control for glare. A bright room is energizing, a glary room is just painful. So the next time you walk into a space and feel amazing, or feel inexplicably drained, just stop for a second and think about it. Is the air in that room actually being changed out? Is the light bright enough, but also free of that nasty glare? Your environment is constantly sending you signals about its own health. The only question is, are you listening?